Hi all, in this video we're going to be looking at more information about graphing quadratic equations, and we've already taken a look at the vertex form, which is f of x equals a times the quantity x minus h squared plus k. And I did want to note just one difference here. I don't have the plus and minus in front of the a. I'm going to now start including the sign with a so that we are more like what everybody else does. So h still is our horizontal shift, k is still our vertical shift. I still need this negative in here, and I need the positive right there. If h is positive, the graph moves to the right. If h is negative, it moves to the left. If k is positive, it moves up. If k is negative, it moves down. Our vertex is still h comma k, and our axis of symmetry is still a line, and its equation is x equals h. So now that we're including a in our, the sign of a in a, the value of a, if a is positive, the graph is going to open up. If a is negative, the graph opens down. So since we're including the sign, now I'm going to say that if a, the absolute value of a is greater than 1, we have a stretch by the absolute value of a. If the absolute value of a is between 0 and 1, then we have a compress by the absolute value of a. But if the absolute value of a equals 1, there is no stretch or compress. All right, so it would be nice if we always got quadratic equations in this form, right? In vertex form, because it really helps us find the vertex really easy. We can see it in our equation. It's just our h comma k value, but they don't always come in this form. And we've seen that when we've been solving quadratic equations. So we have another form for a quadratic equation. It's called standard form. Standard form is f of x equals a x squared plus bx plus c, and we've seen that when we were using the quadratic formula and when we were solving quadratic equations. Well, how can we extract the same information from this form? Well, they give us something called the vertex formula right here, the vertex formula, where you can calculate the vertex. To calculate the x part of the vertex, it's negative b over 2a. To calculate the y part, we just plug negative b over 2a, whatever this calculation is, back into our function to get our k value, right? Or to get our y value. So since I know the vertex, this is my vertex, and I know this is the same as h comma k, I know that h, we can calculate h by doing negative b over 2a. We can calculate k by plugging h into x in our equation. And I can write the vertex form of any quadratic equation in standard form. So I have this a, b, and c here. And I know that my formula for vertex form is a comes from here, x minus h squared, h comes from here, plus k, and k comes from here. So if I can calculate h and k and pull a out of my standard form, then I can write my equation in vertex form. And that's what this whole exercise is going to be. For today's homework is we're going to calculate h and k, find a, write our equations in vertex form, and decide whether things are being shifted horizontally, vertically, whether we have stretches or compresses. We're going to find the vertex, the axis of symmetry, and then look also to see whether our graph is going to open up or down. All right, so here's our first example. Our equation is in standard form. So my very first thing I'm going to do is I'm going to find a. Remember, a is the number in front of our x squared term. B is the number in front of our x term. and c is our last number. And remember, all of these have signs. This 1 was positive, this 2 is positive, and this 3 is negative. So then I know this I'm going to need for my equation. So now I'm going to go ahead and calculate h. H has a formula of negative b over 2a. So I get negative 2 over 2 times a is 1. That's negative 2 over 2, which gives me a negative 1. This is my h value. K, how do I calculate k? Well, I'm just going to plug my h value back into the equation. So I get negative 1 squared plus 2 times negative 1 minus 3. So when I square negative 1, I get 1. 2 times negative 1 is minus 2 minus 3. So when I subtract these, minus 1 minus 3, so I get a minus 4. So that's my k value. K is minus 4. So that gives me an equation since I know, okay, so we call this function f of x. F of x is now going to equal a x minus h squared plus k. So a is 1, h is a negative 1, k is a negative 4. So remember, plug these in using parentheses, and when I simplify all my double signs, I get x plus 1 squared minus 4. Okay, so that's the equation that I'm going to have. So what's happening to my graph? Well, my vertex is h comma k, so that's negative 1, negative 4. My axis of symmetry is x equals h, so x equals negative 1. Since h is negative, my graph is being moved to the left by 1. K is negative. It's going down by 4. A is 1. The absolute value of A is 1, so there's no stretch or compress. A is positive, so my graph opens up. Okay, so that's how we're going to do all of the problems on our homework. So now let's go ahead and move to our next example. We have A. A is the number in front of our x squared term, 1. B is the next number here with its sign, negative 4. C is our next number with its sign, positive 3. This is going to be used in our equation. How do I calculate h? Negative b over 2a. Okay, so our negative b is negative times b is negative 4. 2 times a, which is 1. So we have 4 over 2, which is 2. So that's my h value. My k value, I just take that 2 and plug it in my equation, right? I'm going to take it and plug it in for all my x values. Minus 4 times 2 plus 3. 2 squared is 4. 4 times 2, that's going to be a minus 8. So that's going to be a minus 4 plus 3 equals a minus 1. So that's my k value. So what is my equation going to look like? Well, remember the name of this equation is g of x. So g of x needs to equal a times the quantity x minus h squared plus k. A is 1. H is 2. And k is negative 1. So I'm going to get rid of my double signs. And I don't really need the 1 in front. So there is my g of x. All right, so my vertex is h comma k, so it's 2 comma negative 1. My axis of symmetry is x equals h, so it's x equals 2. H is positive, right? H is positive, so I'm moving right by 2. K is negative, so I'm moving down by 1. A here is positive, so my graph opens up. And since the absolute value of A is 1, there is no stretch or compress. And I think we've hit everything. Okay, so let's move on to our next example. We have A equals 1, B equals -1, and C equals -12. We'll need A for our equation. Remember, the name of our equation is h of x. That's going to equal ax minus h squared plus k. So let's calculate h. H is going to be -b over 2a. So negative b is -1, a is 1. So we get a 1 over 2. So h is going to be 1/2. So now we have to plug that into our equation to calculate k. Okay, so this is h. Let me circle that. Okay, so I have 1/2 squared minus a 1/2 minus 12. So 1/2 squared is 1/4. It looks like everything needs to be with a denominator of 4, so I'm going to multiply this by 2 over 2 minus 2 over 4. I'm going to multiply this by 4 over 4 minus 48 over 4. So what do I get here? I get a minus 1/4 minus 48 over 4 is a minus 49 over 4. That's my k value. All right, so let's just plug those values into this equation right here, and we get h of x equals a positive 1, x minus 1/2 plus a negative 49/4. Okay, so now let's get rid of our double signs. H of x equals, and we don't need that 1 in front, minus 49/4. So this is my equation in vertex form. My vertex is h comma k, 1/2. K is negative 49/4. My axis of symmetry is x equals 1/2. Okay, so h is positive. So that means we're moving to the right by 1/2. K is negative. That means we are moving down by negative 49/4. Our A value is positive, so our graph opens up. Our A value is also equal to 1, so we have no stretch or compress. Okay, so we'll probably have time for one more, hopefully. So here we're missing our middle term. A equals -1. Because we don't have our bx term, b equals 0, and c, remember, is the constant, -9. So this is what we're going to need for our function. Let's calculate h. H equals -b over 2a. So we have negative times 0 over 2 times -1. So that's going to be 0 over -2, which is just 0. That's our h value. K, we're going to plug 0 into this equation to calculate our k value. 0 squared minus 9, that's 0 minus 9, which is just a -9. So that's our k value. So now let's create our equation. F of x needs to equal a times x minus h squared plus k. A is -1. H is 0. K is -9. So when I simplify this, I don't really need to say x minus 0. I can say just x squared minus 9, and I don't really need the